short video clip of some of our school athletes talking about their winning formulas. I think you will see right away the connection between their winning formulas and mathematics. Are you excited yet?
Yes, ma'am.
Okay, let me play the video. Watch closely.
Athletes, human machines. It takes talent to compete in this level, but it takes more than rough ability to win. Different athletes have to think about how they train and how to compete in different ways. Talent has a big part, but probably more important than this is planning and simple formulas. Josh knows about quickness. As a sprinter, his race ends near seconds after the starting gets off. He spends a lot of time in starting technique, the walking to the line, the shaking moves of the muscles, that settling him on the blocks. The intimidating glance.
Actually, I do think a lot about math. The formula for a 100-meter dash is rate times time equals the distance. The faster you come out of the blocks, the faster you get the speed, the faster your time will be.
Joy Castillo is a distance runner. Here are her thoughts of her winning formula.
All I think about is pace strategy to cover a distance of 800 meters. It is very important to think about pacing.
In other words, if Joy wants to win the race, she has to know when to slow down and when to go faster to make her time. So, her trainer has to calculate her average lap time. That is, her total time divided by the number of laps.
If you go out too fast, you'll definitely die. And if you don't go out faster enough, then it is very hard to speed up. So say you're at 220 or 800. It is very important to be precisely at around 70 per lap in order to maintain your speed.
To find a winning formula, these athletes work hard under conditioning and strategy. But sometimes, it is not so easy to figure out. The formula these guys are working on is anyone's guess.
Now, let us talk about their winning formulas. Does anyone recall what Josh, the sprinter, mentioned as his prime consideration when trying to cover a particular distance?
I remember him saying that the faster he comes out of the starting line, the faster his time will be.
I think he said it because rate times time equals distance.
Distance equals rate times time. Isn't that an equation, class?
Yes, ma'am. When you say that one quantity is equal to another, you have an equation.
So, if we let R denote the rate, T the time, and D the distance, how will you write our equation? Is it D is equal to RT? You're right, Denise. It is D equals RT. Now, how about what the distance runner said? Does anyone recall what she said as her winning formula?
I think she said she has to know when to slow down and when to run faster.
Very good memory, Lisbeth. Why do you think she needs to be aware of that?
To conserve energy?
I get it. She's trying to target an average lap time. Knowing the average time it takes her to finish a lap could help her improve her chances of winning.
Very well said, Joyce. And how do we compute the average lap time?
Is it total time divided by the number of laps?
I think it is. Right, ma'am?
Yes. Average lap time is equal to total time divided by the number of laps. We have another equation there. If we use L to denote average lap time, T to denote total time, and N the number of laps, how will this second equation look like? Is it L is equal to T over N? Right again, Denise. You are good at this. Now, do you notice that we have two equations already? D equals RT and L equals T over N.
Yes, the athletes' winning formulas are actually mathematical formulas.
Are you surprised to learn that athletes use mathematics too? In fact, mathematics is found in many fields like science, business, even arts. Of particular interest to us now are literal equations like D equals RT and L equals T over N. With these two examples, can someone describe what literal equations are?
Literal equations are equations with letters.
Yes, that is a good description. A literal equation is an equation comprising of letters, sometimes numbers too. We will discuss more literal equations next meeting. Be ready to present examples of literal equations.
Bye, Sin!
Are you ready with your literal equations for our math class?
I have two from my kuya. The first one is a formula in physics, and the second is from chemistry.
Tell us about them.
First, he says that gases have various properties, which we can observe with our senses, including the gas pressure, temperature, mass, and the volume which contains the gas.
And are those variables related to each other?
Yes, they are, and the values of these properties determine the state of the gas. In the mid-1600s, Robert Boyle studied the relationship between the pressure and the volume of a confined gas held at a constant temperature. He observed that the product of the pressure and volume is nearly constant. This relationship between pressure and volume is called Boyle's law in his honor.
Wow, another law named after a person?
Expressed mathematically, the formula for Boyle's law is PV is equal to K, where V is volume of the gas, P is the pressure of the gas, and K is a constant.
Interesting.
And I have another. According to Newton's second law of motion, the formula for finding force is F is equal to ma, where F is the force, m is the mass of an object, and a is the acceleration of the object.
Very good, Joyce. I have two to share. They are formulas from solid geometry. I got them from my cousin's textbook.
Tell us about them.
The first one is V equals 1/3 pi r squared h. And the second is S equals 2 pi rh plus 2 pi r squared.
So, what about them?
V equals 1/3 pi r squared h gives the formula for the volume V of a circular cone, like an ice cream drumstick, with radius r and height h, like in this drawing.
Oh, I see.
And S equals 2 pi rh plus 2 pi r squared is the formula for the surface area S of a cylinder with base radius r and height h. Take a look at this figure.
Good for you. I also have a couple to present. First, F is equal to P quantity 1 plus I raised to N. This is a formula from business mathematics. It says that the compound amount F is the original principal P times quantity 1 plus I raised to N, where I is the interest rate per period and N is the number of conversion periods. The second one is...
Oops, it's time already.
Good morning, class. I hope you had a great time looking for those literal equations.
We did, ma'am.
Okay, let us start with Joyce. What literal equation did you find? Please write it on the board and share with the rest of the class what it is for.
I have one from geometry. It says that the area A of a triangle with length of base equal to B units and altitude equal to H units is given by the formula A is equal to 1/2 BH.
Very good, Joyce. What about you, Paolo? What formula did you bring?
Mine is associated with music. It says that pitch, or the number of vibrations per second of a guitar with steel strings, varies directly as the square root of the tension and inversely as the length of the string. In symbols, this is expressed as P is equal to K times the square root of T all over L, where P is the pitch, T is the tension, L is the length, and K is the constant of variation.
Very good. Do we have something from, let us say, English?
I have one, ma'am.
Yes, Lisbeth.
It is called the flash reading ease formula, used in determining the readability of a text. The text should have more than 200 words before the formula can be successfully applied. The output of the formula is a number R from 0 to 100, with a higher score indicating easier reading. The average document has a value of R between 6 and 70. The formula reads as follows: R equals 206.835 minus quantity 1.015 times ASL minus quantity 84.6 times ASW, where ASL is the average sentence length, which is the number of words divided by the number of sentences, and ASW is the average number of syllables per word, which is the number of syllables divided by the number of words.
Very good. Isn't that great? A math formula in English?
Ma'am, I have one from manufacturing. Can I share it?
Of course, Gabez. Tell us about the formula.
Well, the formula is about clear tapes. Did you know that when a clear tape is wrapped around a circular cord, its length L, thickness D, inner radius A, and outer radius B are related by L equals pi over T times the quantity T squared minus A squared.
Interesting.
It is indeed another very good example. Now, let us see if you can write the representations of the literal equations, which I will describe one after the other. I have 5 with me. Please listen carefully and take notes when I describe each equation. I will then call somebody to write the corresponding formula on the board. Ready?
Ready!
Number 1. If F degrees is the Fahrenheit temperature reading and C degrees the Celsius temperature reading, one subtracts 32 from F and multiplies the result by 5 over 9 to get the equivalent C reading. What is the formula for C in terms of F? Let me repeat. If F degrees is the Fahrenheit temperature reading and C degrees is the Celsius temperature reading, one subtracts 32 from F and multiplies the result by 5 over 9 to get the equivalent C reading. What is the formula for C in terms of F? Gabez?
C equals 5 over 9 times the quantity F minus 32.
Very good, Gabez. Here is the second equation. If P pesos is invested at the rate of R% at simple interest for T years, and F pesos is the amount of investment after T years, then F is the product of the amount invested and the sum of 1 and RT. Let me repeat. If P pesos is invested at the rate of R% at simple interest for T years, and F pesos is the amount of investment after T years, then F is the product of the amount invested and the sum of 1 and RT. Lisbeth?
F equals P times the quantity 1 plus R times T.
Wait there. You seem to have forgotten your PEMDAS rule, Lisbeth. Remember, multiplication comes before addition. So let me repeat the description. F is the product of the amount invested and the sum of 1 and RT. In the later portion, perform the multiplication first and then do the addition.
I get it. F equals P times the quantity 1 plus R times T.
That is correct. Let us have the third equation. Many problems in physics involve what is known as a lever. A lever is a rigid bar supported at a point called fulcrum. The fulcrum is usually between the two ends of the bar. An empty seesaw is an example of lever with fulcrum at the center. Now, two weights, W1 and W2, at distances L1 and L2 respectively, from the fulcrum are said to be balanced on a lever if the products of their respective weights and distances are equal. What is the formula, Paolo?
W1 times L1 is equal to W2 times L2.
Very good, Paolo. Let me describe the fourth equation. If we use the place value in our decimal number system, how do we express the number n with capital T as thousands digit, small h as hundreds digit, small t the tens digit, and small u as the units digit? Let me repeat. How do we express the number n with capital T as thousands digit, small h as hundreds digit, small t the tens digit, and small u as the units digit? Joyce?
N equals 1000t plus 100h plus 10t plus u.
Very good, Joyce. Now class, let us have the last equation. In geometry, a rhombus is a plane figure which has four equal sides and whose diagonals bisect each other at right angles. Here is a drawing of a rhombus. The diagonals are represented by the dotted lines. The area A is equal to half the product of the diagonals. Paolo, can you give us the formula for A?
The area A of a rhombus with diagonals x and y is 1/2 times the product of x and y.
Very good, Paolo. Well, it seems that everyone had fun expressing physical relations as literal equations. Let us now use some of the equations we have identified to discuss our next topic. Let me choose these ones. Alright class, what do the symbols in the first equation represent?
C represents the temperature in Celsius and F represents the temperature in Fahrenheit. So the first equation will enable us to convert a temperature reading in Fahrenheit to Celsius. What if I want to convert a temperature reading in Celsius to Fahrenheit? Can't I use the same formula?
I am about to ask you the same question. What do you reckon then?
We can just substitute the value of C and then use algebra to solve for F, right?
Quite indeed. In fact, what you really intend to do is to write F in terms of C. This means that F should be isolated. Usually, we write this variable on the left-hand side of the equation and then solve for an expression written in terms of C alone that will give an equivalent value to F. This expression is what we write on the right-hand side of the equation. Can anyone volunteer to do this on the board?
I'd like to try, ma'am.
Go on, Gabez.
Here is the original equation. We use the multiplication axiom to write the equation as 9 over 5 times C is equal to 9 over 5 times quantity 5 over 9 times quantity F minus 32. Simplifying the right-hand side will give us the equation. Since we want to isolate the variable F, the next thing to do is to use the additive axiom. That is, add 32 to both sides of the equation. This will then yield the desired result. F is equal to 9 over 5 times C plus 32.
Well done, Gabez. What does this new equation mean to you then?
I guess this equation tells us that the temperature reading in Fahrenheit is the sum of the constant number 32 and 9 over 5 times the temperature reading in Celsius. It is a formula that will enable us to convert C to F.
You are right about that, Gabez. Now, let us move on to the next equation. Could anyone recall the meaning of each variable in this literal equation?
I'd do it, ma'am. P is the amount of investment. R is the simple interest rate. T is the period of investment expressed in years, and F is the amount of investment at the end of the years. Both P and F are in pesos. The formula says that F is a product of the amount P invested and the sum of 1 and RT.
Suppose we want to solve for the original amount P that was invested. How do we write the new formula then?
Let me try it, ma'am.
Okay, Paolo.
We want to solve for P in terms of all the other variables. So our goal is to isolate P. Since the factor 1 plus RT on the right-hand side is non-zero, we can multiply both sides of the equation by its reciprocal. This will lead us to the equation P equals F divided by the sum 1 plus RT. And this is the equation that we want to derive.
Very good, Paolo. There are 2 more variables in this same equation, right?
Yes, ma'am!
I am then giving this assignment to you. Number 1, write an equation that will give the simple rate R in terms of P, F, and T. Number 2, write the equation that will give the value of time T in terms of P, F, and R. Submit your solutions tomorrow. Okay, class?
Wow, we indeed learned a lot today. So many formulas, so many literal equations.
And from different fields too, not just in mathematics.
Yes, we had literal equations in physics, chemistry, business, and English.
And don't forget music and manufacturing.
Gee, I'm neck deep in equations.
Are we to take you literally on that?